Okay, so today I will be discussing some questions related to vectors. So we'll start with the October 2018 question. They say here relative to a fixed origin O, the line L1 is given by the equation R equals 2, 3 minus 1 plus lambda times minus 1, 4, 3, where lambda is a scalar parameter. Now, when they give you a straight line vector format, what this represents, right? A straight line vector format, we write it as R equals A plus lambda B. A represents a position vector on the line, isn't it? A represents a position vector on the line, while lambda is a parameter. Lambda is a parameter and B represents the direction vector of the line. Okay, so B represents the direction vector of the line. Okay, so then keeping that in mind, now they say here the relative to a fixed origin O, the line L1. So this line 1 is given by this equation where lambda is a scalar parameter. The line 2 passes through the origin. Okay, so that means they have given you a position vector on the line. The line 2 passes through the origin and is parallel to line 1. So what do you understand when they say, now, to write the equation of the straight line, they ask you to find the vector equation for line 2. So simply, how do you find the vector equation for line 2? R equal A plus lambda B. Now in this case, because for line 1, they have used parameter lambda. When you go for line 2, please use a different parameter. Okay, when you go for lines, two straight lines, two different straight lines, you have used two different parameters. Okay, however, the other part, R equal A plus lambda B. So A is a position vector on the line. Now when it comes to line 2, they tell you line 2 passes through the origin. So if line 2 passes through the origin, for A, I can use 0y, 0j, 0k because that's the origin, isn't it? So R equals A plus, instead of lambda, use another parameter. Use any other letter that you can use, S, or you can use T, or since they use lambda, I will go with mu. You can use any letter you want here just to give the parameter, okay? And then it's parallel to line 1. So, for B, we write the direction vector. And then they tell you the line 2 and line 1 are parallel. So obviously lines are parallel means what? If lines are parallel, the direction vectors are the same, isn't it? The direction vectors are the same. So it's minus 1, 4, 3 is the direction vector. Okay. So this is the equation of line 2. Okay, so R equals 0, 0, 0 is the position vector plus mu times minus 1, 4, 3. The direction vector of line 2 is exactly the same as direction vector of line 1 because the lines are parallel. Okay, is this clear? Then we'll move to the next part. They say the point A and point B both lie on line 1 on L1 with parameter lambda 0 and lambda equal 3 respectively. Write down the coordinates of A and the coordinates of B. So this is the point A and B are lying on line 1. So if they lie on line 1, all you have to do is to replace the parameter here and get the respective coordinates. So they tell you here lambda is 0. So when lambda is 0, what do we get? We can get the coordinate A. So let's get the coordinate A. R equals 2, 3 minus 1. Okay, I'm putting for line 1, 2, 3 minus 1 plus lambda is 0. So actually 0 times whatever it is, it's 0, right? So 0 times minus 1, 4, 3 is an entire year 0. So then I get the coordinate of A as 2, 3 minus 1. So this is the position vector of A, isn't it? So here R by R, we get the position vector of A, or the coordinate of A is 2, 3, minus 1 as a coordinate. If you write it down, you write it with the bracket and you put the comma and write it, okay? And then the next one, Roman number 2, the coordinates of B. For B, they say lambda is 3. So R equals A. A is 2, 3 minus 1. A plus lambda is 3. I'm replacing the lambda here with 3. Lambda B minus 1, 4, 3. So let's open the bracket and simplify. 2, 3 minus 1. You can directly add that and get the answer correct. So this is, let me directly get the answer because it's just 1 mark. 2 plus 3 into minus 1. So that's 2 minus 3. Here 3 plus 3 into 4 is 3 plus 12. Minus 1 plus 3 into 3. Minus 1 plus 9. So you can write the answer directly. How much is it? Minus 1. 15 plus 8. Do you agree? So this is the coordinate of B. The position vector of B is minus 1, 15, 8. So coordinate B is minus 1, comma 15, comma 8. So I think all of you are capable of getting this. So this is quite easy. All you have to do is just substitute the lambda value into the main equation and get the coordinate. Okay, I'll move to the next one. Part C, this asks you to find the size of the acute angle between OA and L1. Okay, so how do you get the size of the acute angle between OA and L1? So in part C, the rule is, do you remember how to get the angle between the two vectors? Okay, so how do we get the angle between two vectors? So find the size of the acute angle between OA and L1. So how do you get the acute angle? Normally, if you have two vectors A and B, the theta is found by cos theta is given by A dot B over modulus A times modulus B. This is the equation that we use. Okay, so this is normally the equation that we use. But now, however, they say here, they are asking you to find the size of the acute angle between OA and L1. Now, you do know line. Now, if you come to the theory here, this is just me reminding you of the equation you are supposed to use. So, in part C, okay, find the size of the acute angle between OA and L1. Now, you do realize point A is on the line 1, isn't it? They have told you here point A is on line 1. Okay, so this is your line 1. So point A is on line 1, and then see origin is somewhere else. Okay, we don't know it is. I'll just mark it randomly here. So this is O. So they're asking you to find the angle between OA and line 1. Are you with me? So you're supposed to get the angle between this OA and line 1. Okay. Okay, how do we get the angle between OA and line 1? Okay, so how do we get the angle? Okay, so then here you can consider the two vectors here as we took A and B here. So one direction, I mean, now you can see here we take A and B are the two vectors that are, adjacent to this angle theta. So in this case, you can mark the angle theta to this side, or you could even mark it to the other side. So actually it's fine. They ask you to get the acute angle. So when you get the cos theta rule, in an event, if you get the obtuse angle, all you have to do is to subtract it from 180 and you can get the acute answer. Okay. So anyway, so all you have to do here is to get one vector here is the direction vector of line 1. Okay. One vector is the direction vector of line 1. For the other one, you could use the AO vector to go in this direction, or else even if you want, you could even use the OA line. It actually doesn't matter here, because if you use even if you take AO, or even if you go with OA, you'll either end up with the one answer will give you the acute, the other one will give you the obtuse. Okay, so even if you get the obtuse, all you have to do is just to get the 180 minus of that answer, and you should get the acute answer. Okay, so anyway, I will go with the diagram that I have drawn. So according to the diagram that I have drawn, my vector A is the direction vector of line 1. So what's the direction vector of line 1? That is minus 1, 4, and 3. And then my direction vector B is the AO vector. Okay. So according to what I have drawn, this is AO. So AO is the opposite. Now you do know here, when I get the coordinate 2, 3, minus 1, this is the position vector of A. Position vector of A means position vector is measured relative to the origin. So this is OA. Are you aware of that? So when you write 2, 3, minus 1, the A coordinate, it is measured relative to the origin, which means it is OA. So if you want AO, it will be minus 2, minus 3, and plus 1. Are you with me? So even if you use OA vector here, that is going to be totally fine. Okay, so let me show you why it will not make a difference. Okay, so let's get the dot product. A dot B minus 1, 4, 3. You take the dot product with minus 2, minus 3, 1. What do we get here? Minus 1 into minus 2 is plus 2. Plus 4 into minus 3 is minus 12. Plus 3 into 1 is 3. How much is the answer? So I get here a negative answer, isn't it? So I get here minus 7. Is that correct? I get negative 7 here. How much is modulus A? Modulus A is to get the magnitude of this particular vector. So minus 1 square plus 4 square plus 3 square square root. How much is the answer? Yeah. Okay, so then I took the modulus A here, minus 1 square, 4 square, 3 square, the answer is root 26, and modulus B, the AO vector magnitude was minus 2 square plus minus 3 square plus 1 square square root, which is root 14. Okay, and then let's get the cos theta angle. So cos theta is A dot B, negative 7 over root 26 times root 14. Are you with me? Now, by any chance, if you had taken here instead of AO, if you had got OA, okay, the difference is you would use plus 2, 3, minus 1, and your A dot B would have been a positive 7. That is the only difference, okay? So now when you're typing cos inverse, you should, since you guys are doing P4, you already have an idea about the cost ratio. And you should know if your cost ratio is negative, when you type a negative cost ratio in the cal and take the cos inverse, you should realize that you will get an obtuse answer. You will not get an acute answer. Okay, so if you take it as positive 7 and if you take the cos inverse, you will get the acute answer. Okay, so let me show you. So this is cos inverse. The cal is in degree mode. Negative 7 over root 26 into root 14. So this gives me 111.52. Can you see cos inverse of a negative ratio is it's an obtuse answer. So then 180 minus this, it gives me 68.475, which is the respective acute angle. Or else you could have done it in this manner. You could have gone and put cos inverse without giving the negative sign. This negative sign, we could remove it and give cos inverse 7 over root 26 into root 14, and you immediately get the acute answer. Can you see? So actually it doesn't matter. All you have to do is, if they specifically want the acute, you should realize that the cost ratio has to be positive if they specifically want the acute. Okay. Okay, so if this, so basically you could get the answer here. What would we get? And then you could subtract it from 180 and get your answer. Okay, so entirely up to you how you use this. So 111.52. 5245, and then acute answer, acute angle 180 minus 111.5245. So the answer is gonna be 180 minus 1, that gives you 68.475. Then they want the answer correct to 1 dpu, right? 68.5 degrees. Okay, so I hope you were able to understand what I was saying about this this part here. Okay. Yeah, so they want the answer in degrees to 1 decimal place. So this is the answer in degrees to 1 decimal place. Okay. They say here the point D lies on line 2 such that OABD is a parallelogram. Find the area of OABD, giving your answer to the nearest whole number. Okay. Before you go to get the answer, first let's have a visual idea of what's going on. Now, what's going on in this question? In part D, now because we need to kind of like have a rough sketch of what's going on. Now, you know, you have line 1 and there's line 2. Okay, so line 1 is, so if I draw this is line 1, you know, line 2 passes through origin. Can you see? Line 2 passes through origin and it's parallel to line 1, which means line 2 is a parallel line. Okay, so line 2 has the origin. Okay, line 2 passes through the origin 0, 0, 0. Are you with me? And then they tell you the point A and the point B both lie on line 1. So just mark point A, point B. Point A, point B, they both lie on line 1 and they are parallel and they are, yeah. So they both lie on line 1. Write down the coordinates of A, coordinates of B. Find the size of the acute angle between OA and L1. So we already got the acute angle, isn't it? So we already have the acute angle between OA and line 1. So join these two. So when I join these two, I get the, so here OA and line 1. Okay, so this is just a rough sketch. The angle between OA and line 1, the acute angle was how much? We found the answer previously, 68.5. Am I correct? 68.5 degrees. And then they are saying here the point D lies on line 2 such that OABD. So can't you complete this parallelogram? OABD is a parallelogram. These two lines are anyway parallel. So you have to mark a point D on line 2 such that OABD is a parallelogram. So roughly you can draw a line that's parallel and you can mark the point D. Point D is on line 2 such that these two are parallel. So OABD forms a parallelogram. Are you with me? They're asking you to find the area of the OABD parallelogram, giving you answer to the nearest whole number. Okay, so how do you find the area of the parallelogram OABD? So what we do to get the area of the parallelogram is we divide this by using the diagonal. You know the diagonal of a parallelogram bisects the area of the parallelogram. Thereby, I use this OB line and I draw the diagonal OB and divide this into two triangles. And then I'm going to get the area of triangle OAB, multiply that with 2, and I have the area of my parallelogram. Are you with me? So now what I'll do is, let me get the, to get the area of the triangle, it's half AB sine C. Half AB means the length of the two adjacent sides of this angle. So do we know the length of AB? Okay, so first I have to get the AB line length. To get the AB line length, one method is you could, you know the coordinates of A and B. So you could do x1 minus x2 square plus y1 minus y2 square plus z1 minus z2 square root. Or another method is you could find the AB vector, get the AB vector and get the modulus of the AB vector. So if you can get the modulus of the AB vector, that also gives you the distance between A and B. So there are two methods to get the distance between A and B by using the distance equation. X1 minus x2 square, y1 minus y2 square plus z1 minus z2 square root. Either you could use this, the distance equation, or the other method is where you get the vector AB. AB is B minus A, isn't it? AB vector is B minus A. And then after that, you get the modulus of the AB vector. So both of them, any one of these methods is okay. So I will go with the vector method. Is that okay? B minus A. So I know the B coordinate. What's the B coordinate? Minus 1, 15 and 8, right? B coordinate was minus 1, 15, 8. Yeah. And A coordinate minus with 2, 3, minus 1. Okay, you know the AB vector is B minus A. That is OB minus OA, isn't it? Okay, and then what happens here? When you simplify, minus 1 minus 2 is minus 3. 15 minus 3 is 12. 8 minus 1 is 8 plus 1, 9. So this is the AB vector. Now get the modulus of the AB vector. The magnitude. So when you get the magnitude of the AB vector, it's minus 3 square plus 12 square plus 9 square root. How much is this answer? Can I know the AB vector modulus answer here? So this is 3 root 26 and the other one, the other distance we need to find is the OA line distance, isn't it? So for OA, we already know the OA vector. We already know the OA vector. So I'll get the OA. OA is simply the position vector of A. Position vector of A is 2, 3, minus 1. So this is 2, 3, minus 1. So OA vector modulus is 2 square plus 3 square plus minus 1 square root. How much is it? That is, how much is the modulus of the OA vector? Square root 14,
Root
right?
14. Yeah.
Root 14. And then what you do is, so now we have the distance. I have the OA distance. This is root 14. The distance you can mark on your diagram. The other one, AB distance was 3 root 26. Okay, so now we are ready to find the area of triangle ABO. Multiply by 2, you have the area of your parallelogram. I'll do it over here. So area of triangle ABO. So that's half AB sine C. So half A is root 14, B is 3 root 26 into sine 68.5. Do you agree with me? And then the area of parallelogram. The area of parallelogram will be twice of that. So we'll directly go with the cal and get the answer because we are supposed to get the answer to the nearest whole number. So actually here you can see we are using the 1 dp answer of the theta angle here. But since they want the answer to a lesser significance than 3SF, So I think we can go ahead with this without any issue. So half AB sine C and then times 2. Okay. I just drew this line here so that this root 14. This distance was root 14. Okay. How much is this answer? So when you type everything in the cal, half into root 14 into 3 root 26 into sine 68.5, close the bracket, times 2. So I get 53.253, which means when you round it off to the nearest integer, they ask to give it to the nearest whole number. So that's going to be 53. 53 square units. Okay, so this is the area. You could just say the answer as 53. Okay, so area is 53 square units.